I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we are going to learn strategies to sketch the graph of transformed tangent function. You, of course, need to know the basics about the graph of tan functions, and from there, we'll see the simplest steps required to sketch transformed function. I hope you will enjoy this journey of learning with me. We're trying to help you out in a way to inculcate creative thinking. Now let us see how do we sketch the function y equals to 2 tan 2 pi by 6x minus 1. In this video, we are going to discuss at length how do we sketch a transformed tangent function. The example before us is to sketch the graph of y equals to 2 tan 5 pi by 6x minus 1. I would like you to pause the video, sketch the graph of this tangent function, and then look into my suggestions. My approach is going to be first to understand the graph of tan x. So we'll first understand the graph of y equals to tan x. We will see what are the key parameters. And then we'll adopt a very easy method to sketch. Now, when I say easy method, it really means there will be minimal calculations required for this particular graph. Not only that, we'll also have a general solution. So if you want to understand all this, just watch till the end. So let me begin with the tan x graph itself. Most of you know how to sketch a tan function. As you can see here, the tan function has vertical asymptotes as at minus pi by 2 and plus pi by 2. So these are the vertical asymptotes. And in between the vertical asymptotes, that separation is one particular cycle, and one particular cycle for tan x is from minus pi by 2 to plus pi by 2, and this time period is equal to pi, as you can see here, right? So that is the time period. So let me write down here. Time period is equals to pi. We know at 0, it is 0. Now, the critical point is, what is the value of tan pi by 4? We know tan pi by 4 is 1, and tan of minus pi by 4 is also minus 1, correct? So it's an odd function, right? It's an odd function. So at pi by 4, we have this value of 1, and here we have minus 1 for minus pi by 4. Is that clear to you? So that gives you the other two critical points. Let me call these points as A, B, and C. So for me, the critical points are A, rather I will call this as B, origin, and this I'll calling as A, and this is at C. So these three critical points and the two vertical asymptotes actually define the tangent graph. Now, what is the major characteristics? As you can see, always increasing. So that is how we characterize a tangent function, correct? Now, from here, let us generalize the results. As you can clearly see, if t is the time period, then the vertical asymptotes are at which value? So the vertical asymptotes are at x equals to t by 2 and at x equals to minus t by 2. You can see that, correct? Time period is pi. Pi by 2 plus and minus are the two vertical asymptotes. And these key points are at which value? They are at quarter of the cycle. Do you see that? So these are at quarter of the cycle plus and minus. And you can see it is symmetric about the origin, and we call this as odd symmetry. Keeping these points in view, you can actually sketch tangent function very easily. Correct? I will show you how. Now let us also understand the transformation when we are going to sketch our transformed function. So our function given to us is 2 tan 5 pi by 6 x minus 1. So in this, the value of k is given to us as what? The value of k in this case is 5 pi by 6. From here, we can find the time period. So time period will be pi divided by 5 pi by 6. Pi and pi cancel, we get 6 over 5 as the value of time period. You can write this in decimals as 1.2. So that means, where are the vertical asymptotes? Well, vertical asymptotes are at plus and minus half of this value, which is plus and minus 0.6, half of 1.2. So on the given scale, we can mark the vertical asymptotes first. So this is 0.2, zero point 0.4, zero point 0.6. So we have vertical asymptotes at plus zero point 0.6 and at minus zero point 0.6. Is this part clear to you? So this is vertical asymptote x equals to minus 0.6 and x equals to plus 0.6. Now let's look into the critical points. The critical points which we talked about were, in the original case, on the axis, which is now shifted 1 unit down. So let me sketch the axis which is now shifted 1 unit down, right? So this is at minus 1. So the point which was at the origin, it has now been translated at this particular point. So that becomes our point B dash. Do you see that? So the origin, which was at 0, 0, which was point B, has now been shifted to 0 minus 1, and that is what we are calling B dash. Since the function has been translated 1 unit down. Is this part clear to you? 1 unit down. So we get B dash. Now, how do we get the point A dash? Well, A for us was what? Point A was at quarter of the cycle and its value was 1. Now, at quarter of the cycle, the value is going to be multiplied by 2 since 2 is the stretch factor. So, we should have this as 2 units above. So, actually speaking, and then we have to move it 1 unit down. Now let's figure out where will be A prime. So A prime will be at quarter of the cycle, and this 2 means 2 units above B. You get the idea. So quarter of the cycle will be half of 0.6, which is 0.3. So that is 0.3, right? And it will be 2 units above. That means 1 and 1, 2, right? So there you go. So that is the point which is A prime for us. So the separation between A dash and B dash is of 2 units, A value. You get the idea. So this separation between A dash and B dash is of A units, which is equal to 2. You get the idea. So that is how much you are going above the axis. Similarly, on the other side, we have the value. It is going to go 2 units down from here. So it will be at minus 3. So that will be your point C dash. You get the idea. So let me write C dash slightly above, since the graph is going to be going through this point. So I'll write C dash here. So C dash is also a separation between B and C by 2 units. 2 down. Do you see that? So we have our critical points, and of course we have the vertical asymptote. With that, we can actually sketch our graph. So we have these points, connecting them, we have the graph. You see that. So that is how we are going to sketch the tangent function. Is this part clear to you? So let me do this once again on a new graph paper. So step number 1 is basically to find the time period, which you calculate from k. K is 5 pi by 6. Time period will be pi over k value of 5 pi by 6, and that gives you 6 by 5. Now, from here, we know that the vertical asymptotes should be at plus and minus half of this value, which I can write as 6 by 10 or 0.6. So we are going to sketch the vertical asymptotes at 0.6. Do you see how simple it is? Each division is 0.2, and therefore 3 divisions away will give me 0.6 minus and 0.6 plus on the right hand side. Then we are going to look into the axis. Axis of symmetry has moved 1 unit down. So from 0 we'll go to 1 unit down, and that gives you the point B dash. And then we'll look into the third point, which is stretch factor. So it is stretched. Earlier, the distance between A and B was 1 unit. Now it is 2 units, right? And it is midway between. And therefore, that comes here. So it is 2 units and halfway, quarter of the cycle. Zero point 0.6 gives me 0.3 as half. You get the idea. From the symmetry, we know at minus 0.3, we are going to have a value which is 2 units down, and that gives you the value here. So that is the graph, that is the vertical asymptote which we are approaching Is that clear to you? And that is the center value. And that is how always increasing function is represented by the equation. So I hope these steps are absolutely clear. And that is how you're going to label your diagram finally. Perfect? So it is that simple as that. You have to only take these 3 points, and these points occur at key positions, which are at t, t by 2, t by 4. You get the idea. So once you find the time period, you have actually found the vertical asymptotes at plus and minus t by 2, and then the other 2 points A and C at plus and minus quarter of the cycle. Connecting them with always increasing graph, you have your graph. Is that clear? Feel free to write your comments, share your views, and if you really like my video, you can always subscribe to it. Check our website for new updates. And if you want to learn from me, you can always contact me on the email address given here. Thank you for your time. All the best.